This is chapter 1-5, segment and angle bisector. Please take a second to copy your cuts. Let's start with some definitions. Midpoint. A midpoint is one point that divides a segment into two congruent segments. Okay? It bisects. Okay, so a midpoint, when somebody says midpoint, that means a segment is exactly in half. So I have line segment SR, and Q is the midpoint. It bisects line segment QR, therefore meaning that the length of SQ is congruent to QR. Right, and it's stated here, the point Q divides line segment QR exactly in half. And the three dots here mean therefore. So point Q divide line segment SR exactly in half. Therefore, line segment SQ is congruent to QR. And remember, we talked about this symbol congruent not necessarily meaning equal. Equal means I want a number. If they told me this was 8 and I put SQ is equal to QR, if I put the word equal or the symbol equal, I mean write the 8. But if I say congruent, I mean that they're the same size, same shape. Now, moving further, knowing that SQ is congruent to QR, the red line in the center here indicates that SQ is congruent. They're showing or meaning, because they have the same symbol, that one red line, that SQ is exactly the same length and measure as QR. Now, segment bisectors are just that. Segment bisectors, instead of a point, you may have a segment, another segment. You may have a ray, as we do have here in ray MN. Or we may have another line that divides a segment exactly in half at the midpoint. At the midpoint. The midpoint is point H. Point H is the midpoint of line segment GH. It divides it exactly in half. And you'll know that if I put a symbol with the two lines such that it looks like this here, or these here. So we have here. So ray MN bisects line segment GI at point H. Please remember the symbols, ray and segment. We can calculate, let's say if we're on a coordinate plane, the exact X and Y coordinate of the midpoint if we know the value of both the first point and the second point. This is the midpoint equation with a capital M equals X subscript 1, you may hear me say sub 1, X sub 1, plus X subscript 2 divided in half, or divided by 2. And this is the Y sub 2 plus Y sub 2, Y sub 1 plus Y sub 2 divided in half. This equation again will give you the point that's exactly in the middle of both points. We're going to do an example of this. Let's find the midpoint on this coordinate graph here of point GH. Well, this is a little more difficult because we can clearly see that the two segments here are not easily on an X or a Y place. What do I mean? For example, H isn't directly, point H isn't directly here, so I can just count over and find where the midpoint should be. Because point G and point H are on a diagonal from one another, we got to use a little bit or do a little bit more work. We want to find out where the midpoint would be. Is it here, 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 here? Where exactly is that midpoint? It's a little bit more difficult to determine when we have the 2 points that are on an angle like this. Okay? And so we're going to use that midpoint equation that we just looked at in the last screen here. Capital M equals X subscript 1 plus X subscript 2 that you have written down. Well, what is the value or the coordinate pair? Let's look carefully. We ask ourselves, what's the coordinate pair or ordered pair of G, and what's the ordered pair from H? We should remember how to get that off a graph. G is going to be located at, if this is 0, 0, the origin. G is located at X is -1, Y is 1, 2, 3. So G is going to be located at -1, 3, and H is going to be located where? At a positive on the X, in the X direction, positive 2, up, 2 in the Y, at 2, 2. We need the midpoint equation again to determine where exactly is that M. Here, there, where is it? Okay, and we use that equation to find it quickly. It may not be too quickly, but we'll be able to find it. And again, here's our midpoint equation. And doing this equation, we have to ask ourselves, okay, first of all, I know this is X for my G, and this is the Y for my G. This is my X for my H, and this is my Y for the H. Now, one of these points has to be a 1, so I can let my G be my 1. So that means that the X and the Y are both the 1s. Therefore, meaning X1, Y1. I'm letting my G's be the 1, therefore meaning I'm going to let the H's be the 2. That means both the X and Y will be the 2s. X sub 2 here, Y sub 2 there. Now I can come and substitute, or I can do it the other way around. Substituting. Because I know the midpoint equation, M equals X sub 1. What's the X sub 1? We've named it. Okay? We got the X sub 1 from -1 here, plus, what's the X sub 2? We have to get this from the H, because these are the 2's. The X and Y from the H's are the 2's. So, -1 came from the H sub 1 here, plus the X sub 2, which we get from the H here, divided in half. Now we do the Y's. The Y from the G, and then the Y from the H, and divided in half. Well, what's Y1? Remember, Y1 we got from the G. So it's going to be 3 plus Y sub 2 is the 2 from the H, divided in half. -1 plus 2 in half is going to simply give me 1/2, comma, 3 plus 2 over 2 is 5/2. So my midpoint should be located at 1/2 for the X and 5/2 for the Y. Okay, and if we have it here, my X and Y, how do I do that? Looking carefully on my screen, I have X at 1/2. So this is the 1, I have to go about in a half. And then my Y, I move up 5/2. Well, 5/2 is equivalent to what? Okay? How many roots of 2 in the 5? We have 3 and 1/2. So this will be up 1, 2, 3, and a little bit about a half. Okay? And we should be able to draw this out. Oh, sorry, it should be 2.5, not 3.5. Excuse me. So we have the X, let me back up, the X at 1/2, and the 5 over 2 should be 2 and 1/2 as a mixed number. 1, 2, and the half should be about here. Now we can connect our points. Here. Actually, like so here, about there. Okay? That's your midpoint equation. Sometimes they give you the midpoint, and sometimes you have to find the midpoint. In this particular problem, if you read Finding the Endpoints of a segment, sometimes you will know one endpoint and the midpoint, but you may need the other endpoint. For example, if I have a segment, if this is SR, and I tell you that R is the midpoint, and I need the value over here for T, the other endpoint. Well, I don't know what T is, where exactly, but they give me the 2 values for the first endpoint and the midpoint. I can calculate this last endpoint using the midpoint equation. just simply use what we've done before. Okay, so here we have this equation, the midpoint equation is m, the midpoint equals x of 1 plus, this would generally be the x of 2. Well, this time, this is our unknown value. We don't know what it is. Okay, this would be your second value that you're looking for. That would be this endpoint x right here, but we don't know what it is. What we know is the midpoint's value. We know that because they gave it to us. This is going to be x of 1 plus the x of, which would be 2, but it's unknown, so I use the variable u, divided in half. And then the y sub 1 from the first endpoint plus the y sub u. I use unknown because I don't know where this other endpoint. I only know the first endpoint and the midpoint values. And that's going to be divided in half. Okay, midpoint equals x of 1 plus x of u, unknown. I don't know what that last endpoint is, divided by 2. Y sub 1 plus y sub u in half. Okay? I'm going to pause here. We're going to pick up in class how to solve this particular problem so you can continue your notes once we come to class.